Who's the house?
La L. It does. He's French. Frenchman.
What is that little line next to the L?
That's how you pronounce his name. Le Hopital. You just put Le Hopital. Okay, so we're going back to limits. Okay, I know. Shh, calm down. If you need help, talk to the SPCC people. We have done limits and figured out derivatives with them. Okay, for those who don't remember, our first official limit that we did was this one. The limit as h approaches 0 of f of x plus h minus f of x over 8. Remember doing that one? That's actually a derivative. So we use limits to find derivatives. Well, L'Hopital's rule, guess what he does? He uses derivatives to find limits. Okay? And so what today you're not going to like is, you mean I could have been doing a derivative the whole time? I'm like, yes, but you didn't know a derivative. So that's where everybody usually gets mad at me. They're like, Diaceta, how dare you? I'm like, yeah, but you didn't know what a derivative was, so I couldn't teach it to you.
Every time I say derivatives, my dad's like, what's a derivative? No,
Every time.
And I'm like, slope. He's like, slope of what?
So the tangent line.
Tangent line. It takes me like 10 seconds.
So we really use derivatives to help us with limits with what are known as indeterminate forms. Indeterminate. I have to sound this out because I'm a terrible speller. Forms. Here's some of your indeterminate forms, your famous ones, especially these few ones we're going to use today. 0 over 0 is an indeterminate form. You really can't, remember, the first rule of doing limits is plug it in, plug it in. And remember, you would get like 0 over 0, and I'd be like, no, guys, don't write, the limit doesn't exist. You got to now check your calculator. Remember me saying that? Like, don't just write DNE, because you'll all be like, oh, 0 over 0, DNE. No, it still could exist. It still could exist. This is why. This is an indeterminate form. We can't really say it doesn't exist. If we get infinity over infinity, we really can't say it doesn't exist just yet. It's indeterminate. Okay? Same if we get negative infinity over negative infinity or negative infinity over positive infinity. Those are all what we call indeterminate forms. We can't really decide if the limit exists until we do something else, okay? Either factor it or what we're going to do today, okay? So good old L'Hopital, really, really Bernoulli. I mean, these liars and cheaters in the math area. But L'Hopital's rule says this. Now, it's going to sound complicated. It's going to sound yucky, but you're going to write it down anyway because you're smart children. Okay? All right. It says the limit as x approaches c of a function, if it equals 0, that's the first part. If you take the limit of a function at whatever point c, I don't know, 5, 6, 7, whatever you want to do, and it gets to 0, and the limit as x approaches c of another function equals 0. So you got two limits here. And wait for it, because there's 3 parts to this. The limit as x approaches c of f prime of x over g prime of x. What are those? What are those symbols for? Derivatives. And if I stick this one over this one and take the derivative of it, and I get a limit, meaning I get something out, well then, this is what L'Hopital decided and found out and stole from Bernoulli. Then the limit as x approaches c of f of x over g of x must also equal that L. And you're probably all like, I have no idea what I just wrote. And I'm with you. I remember the days. I hearken back. What this is saying is, if you took a derivative on the top and the derivative on the bottom, and you got a 0 over a 0, or if you plugged it in, got 0 over 0, then you can actually use L'Hopital's rule. This is for the indeterminate form 0 over 0. That's what this rule is for. And we're going to write another one for the indeterminate form of infinity over infinity. Sorry. Totally out there. Well, for a normal one, you just plug it in and get out the normal answer.
That makes sense.
Okay? So here's,
You have to do that anyway to find out that it is.
correct. You still have to plug it in. All right, so if you take the limit of function and let's say you get out a positive infinity or a negative infinity. And you take the limit of another function and you also get out positive or negative infinity. And there's three parts to L'Hopital. The limit as x approaches c of f prime of x over g prime of x equals a limit, equals something. Then I could have said all along then that the limit as x approaches c of the original f of x over g of x also equals that limit. Okay? This is for the indeterminate form infinity over infinity, or I guess plus or minus infinity. All right? So write those down. And again, if you're still like, I just still don't get what you just said, it's okay. We're about to do an example and you will be enlightened. So, L'Hopital, genius.
No. No, the other guy.
He's a thief, yeah, no. No, he paid him. He paid Bernoulli.
Not in royalties.
In royalties, yeah, royalties. Okay, so go back to when we first learned limits. The first rule of limits, and this is what you're going to do on all of tonight's homework. The first rule is, Amy Davis song, plug it in, plug it in. Rule number 2 was factor. Rule number 3 was if you see square roots, conjugate, okay? Rule number 4 was stuff with infinities that we learned, okay? So all that still can apply, but we're going to do a different trick now. We're just going to learn a different trick. So if you plug in 4 right now, 4 squared minus 16, what do you get? 0. What's 4 minus 4? Oh, wait, that is an indeterminate form. If you get an indeterminate form, you are allowed to apply L'Hopital's rule, which says this. Why don't you all just take the derivative of the top for me right now? What's the derivative? Now that you know derivatives, what's derivative? 2x. And just take derivative of the bottom right now. What's the derivative? 1. Now, just plug in your x goes to 4. What do you get? That's the limit. Done.
What's the H above the
L'Hopital's rule. I'm sorry. You didn't know derivatives. I couldn't teach it to you back then.
It's step 1 derivative.
I know, but you didn't.
You could have done 1 lesson.
But you didn't know that.
The first struggle.
All the struggles.
Make yourself feel better.
Thank you, Dusty. Pitchforks. We're coming for you, lady. That's too brute.
You guys want to know?
What did we do before?
Good question. What did we do before that? Do you remember?
Look at our couch and be like.
No, we would factor. This is factorable. X plus 4x minus 4 on top, right? And then the x minus 4s cancel. And then you'd have an x plus 4 left over. And guess what 4 plus 4 is? 8.
But some of them are much harder than that.
Obviously, honey.
And you made us do that.
I'm sorry. All right, let's do this one. So this is the limit as x approaches infinity of 4x squared minus 5x over 1 minus 3x squared. So when we approach infinity, here, before you do anything, I just want you to think with me. If I'm approaching infinity, meaning I'm approaching a very large number, yes? Okay, so if I take a very large number and I square it, and then I multiply by 4, what do I have now? A very even larger number. If I take a very large number and I square it and then I multiply by -3, now I have what kind of number? A very negatively large number. So I have a large number over a very negatively large number. Would you agree? Well, guys, this is an indeterminate form that I'm allowed to then apply L'Hopital's rule. What you used to do, though, I don't know if you remember this, it's a rule, but you could divide everything by x squared. Do you remember doing that? Okay. But we're going to skip that step, and we're just going to apply L'Hopital. Okay? That's why I put this little h, meaning I'm applying L'Hopital. What's the derivative of 4x squared minus 5x? Okay. What's the derivative of 1 minus 3x squared? Okay. Let's now try to substitute in infinity. And what would happen here then? If I substitute in a very large number up top, what am I going to get? Still large number. What about bottom? Still large, negatively large number. Well, guess what I'm going to do again then?
Oh, no. Again.
Let's just do it again. What's the derivative of 8x minus 5? What's the derivative of negative 6x? Hey, guess what your limit as you approach a constant is? Negative 4/3. You could check it on your calculator if you want to, or you could divide this by x squared, divide this by x squared, you'd also get negative 4/3. It's just another way to do what we did in the past. Jack?
What's the little prerequisites, the hospital?
Yes.
Like, how do we know, like, what again is like, what does it mean if the limit at C equals 0?
The limit at 4. So when you plug in 4 on just the top, does that equal 0?
Okay.
If you plug in 4 on just the bottom, do you get 0? So then you have this indeterminate form.
That's F
Mhm.
of X over G.
All right.
Variables change if you're like language different?
Surprisingly enough, not too much. Most like Asian people and still use x and thetas and stuff like that we use.
They're better.
Yes, Jack?
Are there, like, is it usually gonna equal 0? Like, I know, like, most of the time, like, when we're using the
Yes.
thing,
Almost everything that you're doing tonight is going to be 0 over 0, or
but you can't do it if it's.
you cannot do it if you get like 5 over 0 or something like that. However, I'm going to show you one like that, a problem like that, and you're
So
going to,
you would just, like, do regular plug it in?
you would plug it in. Use your calculator.
So if it's undefined, you can't do it?
Yeah. Well, you have to use your calculator. Okay, let's do one more, and I will call these the easy ones. Then we'll do harder ones, and because I have to for my peeps, and then we're done. All right. So if you plug in, because again, your first rule of limits is plug it in, plug it in. If you plug in right now, you would get cosine 0 minus 1 over 0 squared. What is the cosine of 0? 1. Think of your unit circle. And what is 1 minus 1? Oh, so you have 0 over 0. So you're like, hey, well, if I got 0, 0, might as well just apply L'Hopital. And L'Hopital says, then you take the derivative on top, then take, not quotient rule, derivative on top, derivative on bottom. So what is the derivative of the top? What's the derivative of cosine x? And then the derivative of minus 1 is just 0, right? What's the derivative of x squared? 2x, okay? So now that we've applied L'Hopital's rule, let's now plug in 0. What's negative sine of 0? 0. What's 2 times 0? Oh, well, guess what we can do again then? Take another derivative. Now, what do we take derivative of? This guy. Take derivative of the second one. So limit as x goes to 0 of, what's the derivative of negative sine x? Negative cosine x. What's the derivative of 2x? Oh. Now plug in 0. What's the derivative of negative cosine of 0? What's the cosine at 0 again? 1 times negative is negative 1 over 2. The limit is a half.
Sorry, why is it negative cosine? If you're going from.
The derivative of sine is cosine, but then you have a negative out there. Okay, now, I'm going to just pause for a second. I'm going to give you your homework. You're not doing all these problems, so stop fretting. There are 44 of them. If you want to do all of them, by all means, go for it.
Would a basic have done them well?
Yes, you would have.
Like, do really well, so you would have.
These is
He's the hardest failure.
Just ask me why I write my name on my like, literally.
Okay, you are only going to do 1 through, hold on, let me make sure I get this right. Go 1 through 17 odd, cross off 19 and 21.
21?
Yeah, 19 and 21. Then you're gonna do, of course I don't have my sheet on me. Oh, I can't remember now, and I don't have my sheets. 23 and something. Come on. Is that the one? No. I got it. Here we go. All right. You're going to do 1 through 17 odd. Cross off 19 and 21. Then do 23 and 25. Okay? Then 37, 39, and 41. Those are your last three. But because I know you all so well, I'm doing those last three.
But then it won't be 25 or 26.
Exactly. But then everybody's not going to do those two. Because that's really what it boils down to. All right. So you're doing 1 through 17 odd. You're not doing 19 and 21. You're going to do 23 and 25. They're actually not that hard. And then I'm going to do 37, 39, and 41 because I need my SPCC people to get these too. Don't think that that means that you've escaped, children, because you still need to know how to do these. So I'm about to do 37 with you, and then we'll finish off today. Okay? So here's 37. The limit as x goes to infinity of x minus the square root of x squared minus 1. Okay? And I'm going to do some algebra manipulation that you probably never thought would exist. That's why I'm doing these. It's really just for your algebraic skills. If you plug in infinity right now, what do you get out? If you plug in a really large number, what are you going to get out? A large number. Okay, so like, that's not really helping you out. You might have to do something different. You might have to like check it in your calculator or whatnot. And then you're like, well, how do I apply L'Hopital's rule? Well, L'Hopital's rule needs to be in a fraction form. That's the problem. You have to have 0 over 0 or infinity over infinity. So you can manipulate this to be in a fraction. Did you know that? You can multiply anything on top by anything on bottom of anything. As long as these two are the same. Like I could multiply the top and bottom by 5. It doesn't change the problem. Because what's 5 divided by 5? 1. I can multiply the top and bottom by x if I want to. X and x. I'm going to multiply the top and bottom, though, by the conjugate.
You're savage.
I know. All really that is just 1. I'm just manipulating it for a reason. Okay? So what does that do to my problem? Well, let's multiply the top together. What's x times x? X squared. Minus, what's the square root times its own self square root? What happens there? It comes out. Put it in parentheses because you have to distribute that negative. And then the bottom 1 times that would just be that. Okay? So what is x squared minus 1? What do I have left on top now? Not -1, but +1, agreed? Because the negative distributes. And the bottom is this stuff. Now again, remember it's the limit as x goes to infinity. Well, this might be a rule that you have forgotten. So I'm going to make you write it on the side. There was a rule that we had that said this. The limit as x goes to infinity of 1 over x. Do you remember what that became? So think about it logically. The limit as x gets bigger, 1 over 100. What's 1 over 100? 0.01. What's 1 over 1,000? 0.001. What's 1 over 10,000? So where am I going closer to? Okay? So here's what's happening in this problem. As x is getting more and more large, it doesn't matter. The bottom is still an x, right? This is still getting more and more large as x gets more and more bigger. So guess where this is going? 0. So 37, I didn't even apply L'Hopital's rule. And that could happen on this worksheet. Here was an example of me not even applying L'Hopital. Okay? Did you understand that? Kind of. If not, we're moving on. It's really for my SPCC people. I'm sorry. Moving on to 39.
Thanks for your SPC.
You know, I love them, okay?
There's something wrong with the
I feel like
normal
you
guy.
value them.
I do value them more than you. I know, right? I don't.
Value them more than you do.
That's not true. That's not true. All right, let me do this. So this kind of applies to what we were just talking about. Anybody want to think? Anybody want to think what's going to go on here? What we were just doing, can you apply something we just did?
1 over X.
It's gonna be 0.
Okay, I know if you don't, if you don't remember, the limit outside of like an addition or subtraction, you can, I don't want to say distribute the limits, but you are allowed to separate the limits. You can say, oh, the limit as x approaches x approaches infinity of 1 over x minus the limit as x approaches infinity of 1 over e to the x minus 1. You can distribute the limits, quote unquote. Does that make sense?
Yes.
Does this look familiar to you? This is what I just did right here. Oh, so that goes to 0. Boom. Well, this one, let's think of this logically. As x gets more and more big, so e to the 100. Do you remember what e is? E is what equivalent to? 2 point something to the 100. What kind of number is that? Big. All right, what about e to the 1 million? What am I at right now?
Larger.
Even bigger. So what happens there is this is also going to 0. This is just like a 1 over x. So yes, whoever said the limit of this is 0 is correct. Who was it?
Jack.
Was it Jack? Darn you, Jack. It was like it's 0. All right, but the last one. All right, y'all. This one is really everyone else, unless you want to. This is really for my 4 SPCC people in here right now. If you want to, but here, listen, you got to pay attention though. If you want to write it down, you can. If you're an SPCC person, you're writing it down. If you don't want to, you don't have to. Okay. This one is more like what you're going to see. And I'm sorry about it, but
Who has BCC?
yeah.
Yeah, you're right, guys.
I only have like a tiny little bit of.
Oh, wait.
Well, what? No, you do not. If you want to, you can. You do not have to. This is really just more for my ears.
Yeah, I'm not writing that down.
All right. This is really difficult. This is a very, so please pay attention and kind of focus. And if you're not a part of it, please just be quiet so they can listen. You need to listen. If you plug in 0 right now, you would actually end up with the sine of 0 to the tan of 0, which is actually 0 to the 0. Surprisingly enough, this is an indeterminate form, another type of one, which you can manipulate into L'Hopital's rule, which we're about to manipulate. Watch and learn and be amazed. I am going to rewrite this as e to the ln of sine of x to the tan of x. Anybody know why I'm allowed to do that? Because e and ln cancel. Why also am I doing that? Because I want to get tan x down. I don't.
Being there first before you do that.
E and ln can cancel.
I didn't know you could just add both of them.
Well, I can only because they can cancel.
Okay, good. So it's like.
And the whole reason I'm doing that is because I want tan x down. Do you all understand that part? Okay. So I'm actually now going to rewrite this as e to the tan x times ln of sine x. Yes or no? Do you all agree? Pretty much yes or no, my 4 people. Do you all agree? Okay, good. All right. Now you are going to have to kind of come with me on this. When you multiply by tan, that is the same as dividing by cotan. Yes or no? Do you agree with that statement? The multiplication of tan is the same as dividing by cotan. Think about it. If I divide by cotan, same change flip, multiply by the reciprocal will be tan. So I'm actually going to now rewrite this as the ln of sine x over cotangent x. These are the equivalent statements. All I've done is equivalent statements, just manipulating. If I now go to plug in 0 from the right, what you would actually end up with, and you're just going to believe you this with me because I didn't know this until I literally looked at the graph. I was like, I didn't know this at all. I had to look at the graph of this. But when you plug in 0 for the ln of sine of 0, do you even know what the ln of sine of whatever looks like right now? It actually goes to negative infinity. And then when I do the cotangent at 0, it's infinity also. Guess what that is right there? That's L'Hopital. So now I'm going to apply L'Hopital to this guy and this guy. All right, so And E is still there, by the way. Do you do anything with E? No, nothing. You're just going to apply L'Hopital right here. And we're running out of time, so I'm going fast. SBCC people or anybody else, do you remember how to take the derivative of an ln? 1 over. So 1 over sine x times the derivative of this. What's the derivative of sine x? Cosine x. Over, if you don't remember what the derivative of cotangent is, I'll tell you what it is. It's negative cosecant squared x. Then I'm going to simplify this to the best I can. This is cosine x over sine x over, what is the reciprocal of cosecant squared? So it's 1 over sine squared. Same change flip.
Not negative.
Oh, it is negative. Yeah, thank you.
Can you also just make that cosine instead of cosine? Sorry.
Where? Here? I could, but I'm going to leave it in cosines and sines for a reason. Why? Watch what happens. So if I do same change flip, do you know what would cancel? And what would you be left with?
Sine squared to cosine squared equal 1.
And don't forget there's an E here. So it's an E to a cosine x times a negative sine x. Do you all, yes or no, see that manipulation? Okay. Now, plug in 0 again. What's the cosine at 0? 1. What's the sine at 0? 0. So this is e to the what power?
0.
And guess what e to the 0 is? The limit is 1. And if you thought that was fun, surprisingly enough, the one on your SPCC test is actually semi-easier. Semi. All right. Try your best. Thank you for bearing with me. That just is kind of, it's crazy what the way you can do things in math, but, you know, we get to do it. That was fun.
Sometimes I forget that you can literally multiply, add anything as long as you do it's like.
Isn't that crazy?
No.